These exercises deal with the logarithmic scale pH, which is equal to the opposite of the log of the hydrogen ion concentration of a substance. Our first problems give us the hydrogen ion concentration and ask us to find the pH, starting with lemon juice. So for the pH of lemon juice, we will have the opposite of the log of 5.0 times 10 to the negative 3. And this is going to be a place where we can apply the log of a product and write it as the product of as the sum of two logs. So minus the log of 5 plus the log of 10 to the negative 3. And the log of 10 to the negative 3 is negative 3, and so I could write this as the opposite of negative 3 plus log 5, or simply 3 minus the common log of 5. And if we look at the calculator and we enter 3 minus the common log of 5, close the parentheses, we're going to get 2.3. So our first pH is 2.3. For tomato juice, we'll have that the pH equals the opposite of the log of 3.2 times 10 to the negative 4, which, using the same rationale, will end up to be 4 minus the common log of 3.2. I hope I've been saying common log. And this computation will be 4 minus the common log of 3.2, which gives us approximately 3.49 or 3.5. For seawater, we'll have the pH equals the opposite of the log of 5.0 times 10 to the negative 9, which will give us 9 minus the common log of 5, which will give us 9 minus common log of 5, and that is approximately 8.3. And so pH of 8.3. Now we'll go the other direction, and this time they're telling us that for a different batch of tomatoes, our pH, this is tomatoes before we had tomato juice. And so in this case, our tomatoes have a pH of 4.1, and we're asked to find the hydrogen ion concentration. So the 4.1 is going to be equal to the opposite of the log of the hydrogen ion concentration, And so first of all, we can take the opposite of both sides and get that the log of the hydrogen ion concentration for the tomatoes is equal to minus 4.1. By raising each side with the base 10 exponential, we will get the hydrogen ion concentration for the tomatoes is 10 to the negative 4.1. And so if we use our calculator, we'll enter 10 to the power negative 4.1 and get approximately 7.9 e negative 5. So 7.9 e to the negative, or e negative 5, means to multiply by 10 to the negative 5th, and the scientific notation would be 7.9 times 10 to the negative 5 moles per liter. Lastly, we have our milk, and so we would have that the log of the hydrogen ion concentration for the milk would be the opposite of the pH, which would be minus 6.5. So the hydrogen ion concentration would be equal to 10 to the negative 6.5, 10 to the power negative 6.5, enter, and it's approximately 3.2 e negative 7. So 3.2 e negative 7 equals 3.2 times 10 to the negative 7. And so the hydrogen ion concentration for the milk is 3.2 times 10 to the negative 7th moles per liter.